This is topic 8.3, properties from algebra with an introduction to proofs. Lots of the notes here are definitions, so let's just go through some of them. A proof is a series of logical statements, each statement helping to prove an idea being backed by a given definition, a property, a theorem, or a postulate. We use two-column proofs, you'll see in a minute, where you have the statements on the left side and reasons on the right. And you'll see that always the very first step is a given. Given is the information that help you prove a statement. It's the if part of a conditional statement. What you're proving, what you're asked to show using the given, it's the then part of your conditional statement. And then let's look at some algebra proofs. You may have seen these before, but we're going to use some of these when we work through our proofs. The first one's called the reflexive property. If A equals A, everything's equal to itself. You'll see a lot of that in geometry when you're looking at segments that they might two triangles may share a segment, and you'll call it reflexive. Symmetry is just reversing the left and right side of the equal sign. If A equals B, then B equals A. So anything that's on the left side of an equal sign, you can move it to the right, and vice versa. You just flip it. The distributive property, you learned in algebra a lot. If A times the quantity B plus C equals D, then A times B plus A times C equals D. The substitution property, if A equals B, then A may be replaced by B in any equation of the expression. That's it. And a lot of times in the proofs we're going to do, you'll be replacing X, like X will be a quantity and you can replace it. Now the transitive property it kind of shows if two variables or two sides of the equal sign are equal to the same thing, then they're equal to each other. Look at the example. If A equals B and B equals C, then A and C are equal. That's because they're both equal to B. So you actually end up creating another equation. The addition property, that's when you add something to both sides of your equal sign. The subtraction property is just the opposite. It's when you subtract something on both sides of the equal sign. Look at the two examples. If A equals B, then A plus X equals B plus X. The only thing added was the plus X to both sides of the equal sign. And in the subtraction property, you're subtracting the X from both A and B. Okay, let's start looking at some proofs. Two more properties, multiplication and division. If you multiply, if A equals B, then A times X is equal to B times X. That's just kind of what we call balancing the equation. What you multiply on one side of the equation, you have to multiply the other side also. Same goes with division. If you have two sides of your equation or listed and you divide both sides by the same thing, that's called the division property. And these are just examples of the rule. You'll use these in some of the proofs you're doing. Okay, look at the first two-column proof and notice that there's statements on the left side and reasons on the other. Now the first ones we're going to do are algebraic proofs. The given statement on this example 1, and if you look up here, let me point to it. Up here is the given statement, and that is just repeated. Remember, the first part of your conditional statement is the given, and what's behind the then, the hypothesis, the conclusion, is what you're trying to prove. If A is 7 and B is 7, then A and B are equal because they're both equal to 7. We just talked about that. That's the transitive property. Since they're both equal to 7, they're equal to each other. Look at example 2. If X divided by 4 equals 12, then X equals 48. So the hypothesis is the given, The conclusion is what you're proving. I think I'm going to go ahead and show you how the notes, how you got this from the end here. If you look at this one, the only way to solve this problem is to multiply both sides by 4. So if you think of x divided by 4 equals 12, you had to multiply the left and the right side by 4 to get 48. And then the x's canceled on this side. That's why the answer is 48. Now, this is the reason, the multiplication property. If you want to write it in the entire property, it's called the multiplication property of equality. But you can write multiprop. That's enough information to explain the property. All right, look at example 3. The hypothesis is if x times the quantity 8 minus 3 equals 4, then 8x minus 3x equals 4. So remember, your given is your hypothesis, your conclusion is what you're trying to prove. And if you notice on this one, it's called the distributive property. They multiplied the 8 times this x and the 3 times the x. And that's just called the distributive property. So these first 3, they're just going through some of the properties to help you kind of get used to using a 2-column proof where you're writing your reasons on the right side and your statements on the left. Let's try examples on this next page. They're a little bit longer. Example 4. We're given that 3x minus 8 equals 19, and we want to prove that x equals 9. This one has three rows because the second row you're using the addition property. Now when you first start Algebra 1 and you learn about equations, your teacher might say you're balancing the equation by making the by adding 8 to both sides. If you'll notice, that's what was written for the reason, the addition property of equality, and then the result was 3x equals 27. And then to solve a multiplication equation, you divide, and when you divide both sides, you get x equals 9. If you want to show these steps of addition and division, you can. The steps over here don't show that, but you can. Look at example 5. Go ahead and label the left column statements and the right column reasons. This one, the given is up above this box. You see the given statement. That's always the one you want to copy in the first box. So see, this is just the given. That's the hypothesis. You're proving x equals 4, so you know that'll be the what you're proving. Now, it's not allowed to write proof. You can write given on your first line, but you cannot write prove. You'll never be able to use prove as a reason. Okay, to solve this one, you multiply the 3 times the 2x. Let me go ahead and draw a little arrow. If you want to do this, you can, just to make sure you multiply the 3 by the 2x and by the 2. So that's 6x plus 6 equals 30. Now to finish this one, if you remember up on the example 4, where we had to move the minus 8, this one you're going to move the plus 6. So you're going to subtract 6 on both sides. That's why it's called the subtraction property. You can abbreviate this. This is an abbreviation for the subtraction property. And then to finish this one, you divide by 6 on both sides. That's called the division property. You can abbreviate DIV-PROP for division property. Alright, let's go to a little more complicated algebraic proof. This one's a little longer. You notice you have quite a few more rows. Go ahead again and put statements in the left column and reasons in the right. And when you have, sometimes you have 2 givens, and I'm going to go ahead and use a column or a row for each one of those. So on the first row I have the a times the quantity b plus 2 equals 45. And on the second one I have a equals 3. Go ahead and separate those and just write the word given twice. Now if you look at what we did on step 3 right here, the substitution property is I replaced an a. Instead of an a times this parenthesis, I used a 3. This is called substitution. SUBST stands for substitution property. So you substitute in your value of A. And then because you distribute, you use the distributive property. 3 times B, 3 times 2, that's 3B plus 6. To solve this one, since you subtract the 6 first, you get the subtraction property. Then you divide by the 3, that's called the division property. So you explain your statement, how you came up with this answer, with a reason. And you're going to be using the properties that we used in the beginning of this section. I think there might be another page. Maybe this is, no, that's the next section. Okay, you're ready to do some on your own. Let me know if you have some questions and I can help you.